Hello everyone, today we're going to look at some logarithm problems for IB Math. These are kind of blended, higher level, standard level questions. You could get them on either exam and they're going to be helpful in either case. They're analysis application problems, but basically if you're taking IB Maths, this should be helpful to you. We're primarily focusing on log laws here, so it's going to be a lot of problems like this, where we're basically using our logarithm laws to solve equations. There's going to be this video and there'll be a few others. I'll put them together in a playlist so you can go through them, but let's just dive into this example. So this is asking us to solve a simultaneous equation, and I think it's got a really sort of core trick that you have to understand about the problem to be able to solve it. We've got 1 plus 2 log base 5 x equals log base 5 7y, and then we've got this component on here, log base 7 of 6x minus 1 equals 1 plus log base 7 of y. Now the really key thing here is if we try and solve for one of these values, so for x or for y, which I think is often people's temptation, it's going to make the problem a lot more difficult. Instead, we're going to focus on trying to get an equivalent value. For example, we might try and get a log 5 7y in both equations and then use that as the substitution. So we're not going to isolate x, we're not going to isolate y. Just to sort of recap the rules or the log laws that we can follow here, we have, log a plus log b. So if we have two logarithms of the same base that add together, you can write that as log ab. You can do the same thing with subtraction, so you'd have log a minus log b. This is going to give you log a over b. So that's addition and subtraction rules. We're also going to have, let's see, if we do log base 2 of 5, we could write this as log base 3 of 5 over log base 2 of 5. So the reason this is helpful, it's a change of base formula. So this should be a 3 as well. So I've actually written that incorrectly. So it should be log base 3 of 2 down here. The reason this is helpful, it allows us to take one logarithm and represent it in terms of a logarithm of an entirely different base. So we've just chosen 3 here, but I could put any value in here that I want. That's going to be super helpful for this problem. And then the other rule that we want to put in is going to be our power rule. So this is if I have something like a 2 log of a, I can write that as, wait for a connection to restore, that's a bit concerning. Hello? Hello? And we're back, okay. Log of a squared. So we can move that 2 into the power position. It goes inside of the brackets, it becomes log of a squared. And these are our logarithm rules, we'll use them for all of the problems. I'm just going to set this to the side, or kind of move this up here. Okay. Why are you not doing what I want? This is going to let me write on this. It's just, I'm going to reload this. Sometimes that fixes it. Hello? I'm not editing this, I cannot be bothered. You're just going to get this. Yep, here we go. We seem to have just forgotten half of this. Okay, I'll rewrite it. So this is going to be 4 log, it was 2 log of a equals log a squared. And then I'm going to move this over. So using this, I think our change of base is going to be really important. I'm going to focus on log base 7 of y. So my goal is to get a log base 7 of y in this equation so that I can then bring these simultaneous equations together. And I'm going to use that using our change of base rule, using our multiplication rule. So the very first thing I'm going to look at on this first equation is rewriting this as log base 5 of 7 plus log base 5 of y. Okay. Now this is closer to what we have, right? Because we no longer have the 7 in front of the y, but it's still not exactly right. So instead what I'm going to do is this. I'm going to use my change of base now. So this is now going to be log base 5 of 7 still. This, I'm going to give it a base of 7. So on the top we are going to have logarithm base 7 of y. And then the bottom we're going to have logarithm base 7 of 5. So following that log-law pattern that allows us to change the base. Now that I've got this expression here, now that I've got a log base 7 of y, I can use this basically as the thing that I'm going to substitute. So we can say from this other equation that log base 7 of 6x minus 1 is equivalent to log base 7 of y. And that means that I can substitute this in for log base 7 of y, and we get an equation that only has x in it. So how would we do that? Well, I'm just going to plug these back in. So this is going to be plon plus 2 log 5 of x equals log 5 of 7, and then we're going to go plus log 7 of 6x minus 1 over log base 7 of 5. Okay, so we've solved one problem in our equations, right? Our first problem was we had x and y in the same equation, and that was going to make it difficult for us to figure out what x and y should be. Our next problem is that this is extremely complicated, and especially that we have a bunch of different bases on all of our logarithms, right? So these two are 5s, but then here and here we have a 7. So my next sort of job that I'm going to try and do is I'm going to try and get it so that we have everything in the same base. And the reason I'm so interested in having everything be the same base is if we can get our equation down to something like this, where it doesn't matter if it's natural log or log base 10 or whatever base the logarithm has, so long as they have the same base, and I can set up the equations so we've got natural log bracket equals natural log bracket, I can assume based on this that a must be b. Because the only way that the two sides of the equation can be the same is if a and b have the same value. So that's kind of my goal, but in order for me to get to that point, I need everything to have the same base. So luckily for us, if we think about our change of base formula, I'll just sort of drag that down here, we're kind of already set up with a log base 5 in mind, right? Because we've got 5 here, that's like our 2. You'll kind of see this, I think, a bit more clearly when we actually do it. But we're set up pretty well to just turn this back into 5 if I can simplify the top of the fraction. So what we're going to do on the top of the fraction, use our subtraction rule. I just want to focus in on this for a second because I don't want to write it out fully, but I do want to show you why this minus 1 basically just goes away. We have currently log base 7 of 6x minus 1 minus 1. We know from our subtraction division rule that this is basically the same as log base 7 6x minus 1 minus log base 7 of 7, right? Because this is any logarithm with a base and an object that are the same is going to be 1. Why? Because 7 raised to the power of 1 is 7, and a logarithm has the value of whatever power you have to raise the base to get 7. So we know that we can turn 1 into log base 7 of 7. I could also turn it into log base 10 of 10 or anything like that. Really, any value would work. I can then use my division rule to get this. 6x minus 1 over 7. 1 logarithm. And this, I'll just sort of plug this back in. We're going to come back over here. We're going to have 1 plus 2 log base 5 of x equals log base 5 of 7 plus log base 7 6x minus 1 over 7 log base 7 over 5. And then we use our change of base formula to turn this piece at the end into log base 5 of 6x minus 1 over 7, just like that. And this just, I want to make sure this is super clear, right? Because this is kind of a complex process we've gone through of turning it from 7 to 5, or from 5 to 7, now we're going back to 5. The formula we're using is if you have log base a of b, right? So the base is a, the object is b. I can write that as log base c of b over log base c of a. So basically in this situation, our 5 here is the equivalent of our a, which is why it ends up going back here as the 5, in the same way that the a is down here. So I'm just sort of going back from this change of base formula, I'm going back to the original, where 5 is the base, but now we've got this 6x minus 7 in the object. Let's sort of move on and look at the rest of this. We can see here, and this is going to be super helpful, that I have a log base 5 of 7. Some of you may have guessed what we're doing next, which is, this is basically addition formula, right, from our list of formulas. We have two logarithms, they've got the same base, they've got no coefficients, right, it's just log 5 of something plus log 5 of something. I can multiply this and this together and make one logarithm. One logarithm that is helpfully log base 5, 6x minus 1, just 6x minus 1. I started putting the 7 in. I don't need it because it's divided by 7, multiplied by 7. Just becomes 6x minus 1 again. So our left-hand side is what I am going to pay attention to now. We've done, I think, a very good job of starting from the beginning, getting it down to, like, on the right-hand side, a much simpler expression. So far, we've really been neglecting what's happening on the left-hand side, but it's time for that to change. Okay, what can we do here? What kind of rule can we follow? Well, I've got a 2 here in front, and I've got a 1 here. I can rewrite the 1. I can rewrite the 1 in terms of a base of 5, like this. Log base 5 of 5, because 5 raised to the power of 1 is 5. So any number any 1, I can just rewrite as logarithm of a number, object of the same number. We add, what am I going to do with this? I have a 2 in front. I really want to bring these together, collapse them down into one logarithm. So that 2 is kind of unhelpful for that. I'm going to move it into the brackets. I'm going to make this log base 2 x squared. And now we have log base 5 of 5, log base 2 of x squared. I can use my addition formula, log base 5, 5x squared equals log base 5, 6x minus 1. Now, why is this so important? We're now in that sort of perfect position. The natural log of whatever equals the natural log of whatever. Since the structure here is identical, log base 5 on both sides, and then just the brackets, what do I know for certain? I know these have to be the same. I know 5x squared must be the same as 6x minus 1. And we're finally free of all of the logarithms, and we just have this problem to solve. It's a quadratic problem, so I'm going to move everything over to one side. I think this is non-calculator, so I'm going to just do this by hand. Obviously, we're now at a point of solving a quadratic, right? There's lots of different ways to do this. Quadratic formula, factoring, AC method. I'm going to just try and factor this kind of quickly without any kind of formal method. We'll see how that goes. Because I know that these two numbers at the end are going to have to multiply to 1. So it's a negative 2. So I'm going to assume they're both actually negative 1 because of the negative in the middle. And then I think in front we're just going to have 5x and x, since the first two values need to multiply together to make 5x squared. Would that work? 5x times x is 5x squared, minus x minus 5x would give us the minus 6x, and then minus 1 times minus 1 gives us the positive 1 at the end. So x is 1, or x is 1/5. I've kind of gone through the quadratic here fairly quickly, but I think if you need help solving this kind of quadratic, look for that separately, right? We'll probably do some videos on quadratics, but I would go and revise that separately. I'm not going to spend tons of time taking my time on a quadratic on a logarithm problems. Hopefully I've not made a mistake. So x is 1/5, x is 1. Now I'm just coming back up to check, because we're supposed to not have any minus values in our logarithms. So I'm just trying to checking where x is up here. Those both seem fine. So it seems like both of those solutions aren't going to give me a negative number in my logarithm. Now that I have those solutions, let's see, is there any kind of nice way to do this? We're going to have to find our y values. I'm going to use, I think, Let's just use this. Let's use this. Okay. So 1 plus 2 log 5. Let's see if I can remember it. Bear that in mind and remember it. 1 plus 2 log base 5 of y. And then what was the right-hand side? It was like... I've completely forgotten. Log base 5 is 7y. Log base 5 of 7y. Okay. Now, what I'm going to do here is a bit of a trick. We've already worked on rearranging it on the left-hand side, so I'm just going to skip ahead to that bit. Because this was all the same. So this is going to be 5x squared. Was it? It can't have been y. It must have been x originally. Yes, it was. I've just copied that down wrong. X here. You're going to be checking for these mistakes. I make so many of them. And then log base 5 of 7y. And then, helpfully here, we can extract just a relationship, right? Now this is not in terms of x like it was over here, but I've just got a relationship between the value of x and the value of y. So it's sort of y will be 5/7 of whatever x is squared. And if x is 1, that means we're going to have, an x equals 1, y equals 5/7. And then when x is a fifth, I guess that's like 5/7 times 1 over 25, right? Because 1/5 times a fifth is 1 over 25. Those 5s will cancel though, so we'll just be left with, I guess, 1 over 35. That would be our other solution, right? X is a fifth, y equals 1 over 35. Our solution set down there. I'm just going to put it in a box. A box that randomly draws a line through it. Brilliant. Okay, there you go. So, to recap this, because there's just a ton of things going on. This is a really challenging problem in terms of applying and using our logarithm laws. And if you're not really across these rules, one of which I've just stolen and moved somewhere else, but this is our change of base, right? So this is our log AB is log C of B over log C of A. This is going to be a really hard problem if you've not mastered those 4, because we keep using them. Most of them we're using several times. The key thing is to pick apart a part of both equations that we can use as a substitution. Just trying to rearrange for y really isn't an option here. We picked out this part, so we go through the process of figuring out how to get log base 7 of y in our first equation, and then we use that substitution from our second equation, and then we go through this really kind of horrible process of rearranging and simplifying our equations till finally we get down to this nice cute little quadratic that we can solve at the end. This is a really challenging problem. I mean, for HL, this is hard. I don't think you'd see something like this on SL, but it is. This is a HL past paper question, but it's using the rules you need to know for standard level. But it's a challenging problem for sure.